Hello, welcome to Homework Walkthrough Video 7.04b, Independent Practice. Let's jump right in. Question 1. A 6th grade class just got their scores back from a science quiz. The teacher created a box plot to show an overview of the science quiz scores. Here is the box plot. Answer the questions to describe the data. The box appears to be fairly symmetrical or skewed. If a box plot has a really long whisker, or one of the 4 parts of the box plot is really longer than the other ones, that means it's skewed. So like if there's a super long whisker, or a super tiny whisker, or a super long box, super tiny box, then it's skewed. Otherwise, it's fairly symmetrical. They all look about the same size of whisker, about the same. Some are bigger, that whisker's bigger than that whisker, but it doesn't look crazy to me, so I'm going to say fairly symmetrical. The middle 50% of data lies between blank and blank. On a box plot, each portion represents a quarter of the data. So this is 25%, or a quarter of the data, 25%. This is 25% of all the numbers. This is 25% of all the numbers. And this, even though it's the smallest, is still 25% of all the numbers. That means this section, those numbers are really close together, not as spread out. So this question is asking the middle 50% lies between which 2 numbers? So our middle 50%, so from here to here, our middle 50%, 25, 25, 50%, lies between what 2 numbers? Well, it looks like this number is 90, and this number is not 70, 69. So between 69 and 70. No, 90. Close one. The lower 25% lies between what 2 numbers? The lower 25% lies between what 2 numbers? So now we don't want the middle 50% anymore. We want the lower 25%. So the lower quarter of the data. What 2 numbers does it lie between? This is the number 60, and here, it's the number 69 again, like we used before. This lower whisker starts at 60, ends at 69. 60 and 69. It's where the lower 25% lies between those 2 numbers. Part 4. Question. 75% of the data lies between 69 and 75% of the data lies between 69 and what? 69 and 60? No, that's only 25% of the data. So not 69 and 60. Is it between 69 and 78? Is that 75% of the data? Nope. That's only 25%. What about between 69 and 90? Is that 75% of the data? Nope. What about between 69 and 95? Is that 75%? 25, 25, 25. Oh yeah, that is 75. 95. 3 sections. 69 to 95 is 3 sections of the boxing whisker plot. 95. You. Question 2. A meteorologist is studying a daily high temperatures for a city in February. He created a box plot to show an overview of the high temperatures for the month. Here is the box plot. Answer the questions to describe the data in the box plot. box appears to be skewed, fairly symmetrical. If the box has one section that's way bigger than the other sections, it's probably skewed. If all the sections look about the same, like in question 1 up here, it's probably fairly symmetrical. They're not perfect, but they're fairly perfect, fairly similar, almost similar. Here, we have a long whisker, way bigger than the other parts. So that means it is skewed. That means it is skewed. Now our next question is, the middle 50% of data lies between blank and blank. The middle 50%. On a box and whisker plot, each section, each whisker, each box represents 25% or a quarter of the data. That's why there's 4 different sections of a box and whisker plot, because there's 4 quarters. Even this big section is still only 25%. That means in this top quarter, the hot days are really spread out. They're not close together like here. They're spread out days. Really lonely. Our question is, the middle 50% of data lies between what 2 points? So our middle 50% would be here and here, between those. Cool. So it looks like this is not 45, but 44. And looks like here, it's not 55. It's also not 56, but in between those. 55.5. This is our middle 50%. 25 and 25 is 50. 44, 55.5. The upper 25% lies between what 2 numbers? The upper 25%. The upper 25%. So that is here, the upper 25%. It lies between right here, right? That upper quarter, that highest part of our data is really long, really spread out. It's these 2 numbers. That is the upper 25% of our box and whisker plot. Here it starts at 55.5. We know that, between 55 and 56. And then here it looks like it's 80. So our upper 25% of data lies between 55.5 and 80. 5.5, 80. 75% of the data lies between 40 and 75% of the data lies between 40, so here, and what other number? 40 and 80? Is that 75% of the data? Nope, that's 100%. What about 40 and 44? Is that 75% of the data? No, that's only 25%. So it's not 45 and 44. What about 45 and 49? Right here. Nope, that would only be 50, 25 and 25. That's only 50% of the data. So not that. What about 55.5? 25, 25, 25. Oh, 3 quarters makes 75. 25, 25, 25 is 75. So looks like looks like 75% of our data falls between the number 40 and 55.5. Check. Yeah. Question 3. A tree farm owner collected data on the heights of their apple trees ready for selling. She created a box plot to show an overview of the heights of her trees. Answer the questions to describe the box plot. The box appears to be fairly symmetrical or skewed. If one of the four sections of a box and whisker plot is way bigger or way smaller than the other sections, then it's skewed. It's not normal. If all of the pieces of a box and whisker plot are almost the same, like up here in question 1, almost the same, then it's fairly symmetrical. Here we have a whisker that looks way bigger than the other pieces, so I think it's skewed. Our next question is the middle 50% of data lies between blank and blank. On a box and whisker plot, each section represents 25% of the data. So in this section, the data is really spread out, but still there's maybe 4 numbers here in this section. Here, the numbers are a little closer together. There's still, maybe again, only 4 numbers in this section. Here, the numbers are even closer together. It represents 25% of the data. So here, there's also maybe 4 numbers. I'm just guessing, just picking a random. And here, another 25%, also 4 numbers. Each of these sections have the same amount of numbers in each of them, but the bigger the section, the more spread out it is. The smaller the section, the closer together those numbers are in that section. So we want the middle 50% of the data. Middle 50%. So I think that's here and here. Middle 50%. What 2 numbers does this lie between? Middle 50%. 6. So this is 7. So not 6, not 7, but 6.5. Looks like 6.5. And then this is not 10, not 12. That number right there is 11. So that means this is 10.5. So between 6.5 and 10.5. The upper 25% lies between what and what? The upper 25%. So we want this upper 25%. What 2 points does the upper 25% lie between? I think this is 10.5. We use that just barely. And here it's 12. This number I think would be 13. Follows the same pattern. Or no, not 13. That number would be 14. And this would be 13, because every tick mark is going up half, going up 0.5. So between 10.5 and 13 is the upper 25% of our data. "75% of the data lies between 0.5 and 0.5 and so 0.5, so that's the number 1. That means this is 0.5. So 75% of the data lies between this and what else? This and here? Nope, that would only be 25% of the data right there. So not that. What about between 0.5 and the number 9? Is that 75% of the data? Nope, that's only 50%. What about between 0.5 and 10.5? Is that 75% of the data? Yeah, 25, 50, 75% of the data. Here we go, 10.5. That's a really popular one, 10.5. And check. Yeah. All right, question 4. Oh, back to that 6th grade class. Got their scores back from a science quiz. Teacher created a box plot. Box plot. Now, let's find the range and interquartile range. To find the range, we do the biggest number minus the smallest number. Here looks like our biggest number is 95, and our smallest number is 60, so we do 95 minus 60, 35. Interquartile range, IQR, is very similar to range, but instead of doing the biggest number minus the smallest number, we do quartile 3 minus quartile 1, or the ends of the boxes minus each other. So this box, quartile 3, this line minus quartile 1 over here. So quartile 3 is 85, 6, 7, 8, 88. Down here is 65, 66, 67. So quartile 3 is 88. Quartile 1 is 67. Let's minus those. 88 minus 67. Answer is 21. Yeah. Question 5. A meteorologist is studying daily high temperatures for a city in February. He created a box plot to show an overview of the high temperatures for the month. Box plot. Find the range, interquartile range. To find the range, we do biggest number minus the smallest number. What's our biggest number for this box plot? Yeah, it's 80. What's our smallest number for this box plot? Nice. 41. So to find the range, we would do 80 minus 41. 39. Interquartile range, or IQR, is very similar to range, but instead of doing the biggest number minus the smallest number, we do quartile 3 minus quartile 1, or the middle of the big numbers minus the middle of the small numbers, the end of the box minus the beginning of the box. What is quartile 3? Yep, it's 61. What is quartile 1? 45, 46, 47, not 47, not 48, but it looks like it's right in the middle, so 47.5. So quartile 3 is 61, quartile 1 is 47.5, so let's minus those. 61 minus 47.5, 13.5. A tree farm owner collected data on the heights of apple trees ready for selling. She created a box plot to show an overview of the heights of her trees. Box plot. Let's find the range. To find the range, we do the biggest number minus the smallest number. Biggest number minus the smallest number. What is our biggest number here? Not 12. Looks like every tick mark is half. So 12, 12 and a half. So 13 looks like the biggest number. What about the smallest number? Oof. Looks like where every tick mark is a half. So that's 2. That's 1.5. This is the number 1. So this is 0.5. Biggest number is 13. Smallest number is 0.5. To find the range, we subtract the biggest by the smallest. 12.5. That is how much all the numbers vary. Interquartile range, or IQR, is very similar to the range. But instead of doing biggest minus the smallest, we do quartile 3 minus quartile 1. It's like finding the range of the middle 50% of the numbers. So let's find that range of the middle 50%. Let's find that interquartile range by doing the biggest of the box numbers minus the smallest of the box numbers. What's the biggest of the box numbers? Not the number 10, but it looks like we're counting up by halves. Every tick mark is half, or 0.5. So that's 10. This is 10.5. That means this is 11. 11. Here, oh, it looks like it's covering up the number. Let's see if I can count up to it. 4, 4.5, 5, 5.5, 6. So the biggest of the box numbers is 11. Quartile 3 is 11. The smallest of the box numbers is 6. Quartile 1 is 6. So to find the interquartile range, the range of the quartiles, let's subtract 11 by 6. 11 minus 6 is 5. You probably could have done that in your head. So could I. But sometimes it's nice to use that calculator. 4 points. All right, if you need more help with this homework, let me know. I would love to help however I can. Good luck and goodbye.